Okay, so four causes of hypochromic microcytic anemia, but only one or two principles. The first principle is this: if you have decreased serum ferritin in the bone marrow, means in the bone marrow macrophages or macrophages, whatever, wherever decrease in ferritin in macrophages, it is the positive signal to the liver to increase synthesis of transferrin, which is basically the same as total iron binding capacity. Okay, so if you have decreased serum ferritin, you will have increased total iron binding capacity by the end. This is the first principles. The second one, how about the iron saturations? Iron saturation, according, there is an equation for iron saturation which is equal serum iron over total iron binding capacity multiplied by 100. So let's apply these two principles on four examples. Okay, let's divide the page into four. Okay, let's four examples. First, you have here iron deficiency anemia, and here you have anemia of chronic disease. Okay, here you have another color. Let's take this one. I think this is the same. Here you have thalassemia, and finally here you have what? Sideroblastic anemia. Okay, sideroblastic anemia. Okay, how about iron deficiency anemia? Iron deficiency anemia problem. First, the problem you have, the first thing in iron deficiency anemia, you have decreased serum ferritin. That means storage system decrease. So if decreased serum ferritin according to this equation means you have an increased total iron binding capacity. So this is the second thing, or the second change in iron deficiency anemia. How about serum iron? As a result of this, serum iron serum iron, when you have run out of the storage system, you will have decreased serum iron in the blood, which means in decreased serum iron attached to transferrin. How you know the saturations or percent of saturations? Yeah, you can't say of this percent with the same saturations. If you have decreased serum iron, which is according to this equation, decreased serum iron and more total iron binding capacity, mathematically this will lead to the decrease iron saturations. And you can also imagine this: if you have a lot of transferrin, here you have a lot of transferrin in the blood, okay, but unfortunately you have only few irons. That's mean transferrin saturation is less than third. Usually, normally transferrin saturation is less than third. Normally third or 33%. So if you have less than 33%, which is transferrin saturation, with all of other features, other criteria, so now you will have iron deficiency anemia. Okay, iron deficiency anemia. And how about anemia of chronic disease? Basically, the mechanism of anemia of chronic disease. Oops, sorry. Here you have inflammation, and as a result of inflammation you have hepcidin. What usually hepcidin do, and we discussed this in this second video, so iron will go inside the macrophages. Here is the macrophages. Iron will go inside the macrophages and stored as what? Stored as ferritin. But unfortunately iron will not go out because there is a specific kind of protein which is receptors which is inhibited by hepcidin. So as a result, serum ferritin what? Serum ferritin increase. So as a result of if we can apply this to the same equations, serum ferritin increase, that's mean total iron binding capacity. What happened to total iron binding capacity? Decrease. Okay, and how about serum iron? Serum iron, here you will not have iron you will not have iron coming out, so the serum iron as a result of this will be decreased because you will not have iron going out of the macrophages. So basically the iron, which is it's already in the blood, all the iron from the blood will get trapped inside the macrophages as ferritin, and the iron will not be able to leave macrophages, so the serum iron in the blood will be decreased. How about the saturations? According to the equation, if you need to measure the saturation, according to the equation, so serum iron will decrease and total iron binding capacity will decrease. So saturation definitely will decrease because you will not have total iron binding capacity, which is transferring, and you already don't have iron. Okay. How about thalassemia? Basically, in thalassemia you have globulin problem. okay, proglobulin problem, you will not have you don't have any heme problem. So here all iron indices are what? Normal. That's it. That's it. So I finished now with thalassemia. Okay, all iron indices in thalassemias are normal because you don't have your problem is in globulin, not in the heme. Okay. How about sideroblastic anemia? Sideroblastic anemia, you can say about sideroblastic anemia, it is iron overload disease. What do you mean by iron overload? Like hemochromatosis. How? So you have increased a lot of iron in the blood and a lot of ferritin in the blood. Okay, we'll go to the liver signal. Total iron binding capacity. Actually, here some book said decrease, some authors said normal. It's okay. Okay, it's okay. Decrease, according to our principle, is decrease. If you have an increased serum ferritin, you will have decreased total iron binding capacity. Okay, and how about saturation? I think it's so easy. Saturation is in hemochromatosis definitely more than 30%, more than 33, maybe 45. So saturation will be more and more. And according to this principle, also you have a lot of serum iron, more, and decreased total iron binding capacity a lot. So if you need, according to the equation, serum iron, a lot of serum iron, total iron binding capacity decrease. So as a result of the saturations will be increase.